Today I'm going to discuss this 16th lesson with you. So, changes in matter. Objects made of iron rust when exposed to air. Mothballs become smaller in size when kept exposed to the air. Ice melts turn into liquid water. We have seen changes in matter like this. To study them further, let us do the activity 16.1 given below. What happened? Objects made of iron, the iron objects, they get rust when exposed to air. Mothballs, they become smaller. You know what is mothballs? මේ අර කපු මේ කපුරු කියන්නේ කපුරු, that is mothballs. So it becomes smaller in size when kept exposed to the air, and ice melts and turn into liquid water. We have seen changes in matter like this. Happen. These are things we have normally observed. Then activity 16.1. Requirements: a piece of magnesium ribbon, about 50 milliliter of dilute H2SO4, a few pellets of sodium hydroxide, 2 metal spoons, a mothball naphthalene, a box of matches, 250 milliliter beakers, a Bunsen burner, and a thermometer. So there are different activities to do. First one, heat the metal spoon strongly in Bunsen flame and take it away from the flame. Place a mothball on it and observe. Close it with another spoon quickly. After some time, observe the inner side of the spoon. First you have to heat the metal spoon strongly in Bunsen flame. Then take it away from the flame, place a mothball on it and observe. Close it with another spoon quickly. After some time, observe the inner side of the spoon. So this is the observation of that practical. Mothball melted and vaporized. So it not only get melted but also vaporized. A white powder deposited on the inner side of the spoon. So the second one, hold a piece of clean magnesium ribbon with pair of tongs and burn it. What happened? You already know this thing. Magnesium ribbon burned with a white bright flame, leaving a white powder. What is end product? It is a white powder. Sodium hydroxide dissolved are here. Measure the initial temperature of dilute sulfuric acid solution. You have to measure the initial temperature of dilute sulfuric solution. Okay. Initial temperature of dilute H2SO4. Add a few pellets of what? Sodium hydroxide. Then stir, and after stir for some a little time, then until all the pellets get dissolved, then you have to measure the temperature again. Sodium hydroxide dissolved and the container become hot. The thermometer reading rose. Okay, that means risen. Has risen. Fourth one, put a piece of magnesium ribbon to a beaker containing the dilute H2SO4. Magnesium with H2SO4. Magnesium ribbon dissolves, liberating gas bubbles. You later know this is a hydrogen gas. So the beaker was heated. These are the observations. So these are the normal common practicals we could observe. Nice observations. So in case 1, above solid naphthalene melted, mothballs, they melted and then turned into vapor. First they melted, then turned into vapor. On the cold surface of the spoon, the vapor solidifies. First, when we burn it, when the spoon is burned in the Bunsen burner, it get hot. So the solid naphthalene get melted and vaporized. But when we close it with the cold um, spoon, that vapor gets solidified, so it goes backward. So solid turn into liquid, then liquid turn into vapor. But after you cooled it by using another cold spoon, that vapor convert into melted and quickly it get into solid state. Okay, so vapor solidified. This is what happening there on cold surface. Okay, forming a thin solid layer of naphthalene. Okay, when solid naphthalene melted, liquid naphthalene vaporized and naphthalene vapor solidified again, and only the physical state. So this is the only physical state of the given substance change without giving new substance. Such changes are called what? Physical changes. You already know these things. We have discussed them in earlier grades, but here we are going to discuss it again. So memorize them. Otherwise, the knowledge I am giving you right now is enough to learn these things. In the instances from 2 to 4, the given substance forming new substances. Such changes are known as chemical changes. So they are different from physical changes, because physical changes we can obtain the initial state of that thing easily by melting, or by yeah by removing the heat or adding the heat. We can change the state, and sometimes we can obtain the thing which we had at first. But when it comes to chemical changes, its nature is completely changed and we can't recover it. Okay, observations such as burning with the flame, evolution of heat, effervescence, change in color, and precipitation can be given as evidences for occurrence of a chemical reaction. To investigate physical and chemical changes further, let us study about 16.1 table. Physical changes and relevant observations. Chemical changes and relevant observations. So here we have the definition. The arrangement of particles which form the substances change. No new substance are produced. As an example, crushing a stone, so the lumps turn into powder. Melting of wax, solidity turn into liquid. Vaporization of water, liquid turn into gas. Condensation of water vapor into droplets, that is gas convert into liquid back again. So we have the same structure of the initial product. The structure means the same compound, but the arrangement of particle has been changed. But when we come to chemical changes, the existing substance are undergone changes and new substances are formed. Examples: burning firewood, formation of ash and liberation of gas, and we cannot obtain the initial what? We cannot obtain that initial firewood after we burn it. Okay, so liberation of gases and formation of ash happened. Then when we talked about heating limestone, formation of calcium oxide, evolution of gas happened. Heating limestone, formation of calcium chloride and evolution of gas. After that we cannot obtain limestone. Heating potassium permanganate, calcium oxide, gas. Heating potassium permanganate, so liberation of oxygen happens. Rusting of ions, formation of rust. We cannot remove it. We cannot, we can remove it, but we cannot make that rust into that iron back again. Okay. So chemical changes, from here we are going to learn about chemical changes, changes in matter, under the topic changes in matter. Chemical changes, one of the following can happen during a chemical reaction. Formation of new substances by the combination of two or more substances. Okay, so this is the first thing. Formation of new substances by the combination of two or more substances. Turning one substance into two or more substances, or reorganization of initial substance to form new substances. Sometimes new substances are formed by combination. Sometimes one substance is turned into two or more. That means it is not combination, it is a kind of what we call it a decomposition reaction. Okay, so it is one substance decomposed into two or more. First one, it is a combination. Third one, reorganization of initial substance to form new substances. Okay, let's see. The substance taking part in a chemical change are called reactants. The new substance produced by a chemical changes are known as products. So, during a chemical reaction, reactants turn into products. To study the variety of chemical changes, let us engage in activity 16.2. Activity 16.2 requirements: magnesium ribbon, zinc granules, potassium permanganate, barium chloride, sodium sulfate, boiling tubes, test tubes, Bunsen burner, an iron plate, a dry equal, a box of matches, a pair of tongs. Hold a magnesium ribbon in a Bunsen flame with a pair of tongs. What happened? Here we have the nature of the here we have the table for this chemical reaction. Burning magnesium in air. Nature of the reactant: shiny silvery white metal. Reactant. So this is the nature of that magnesium ribbon. Okay, a piece of magnesium ribbon. So it has shiny silvery appearance. It's white metal. And observation: burns with a bright white flame. And nature of the product: what is the product? A white powder. So you have seen this thing. Second one, heat crystals of potassium permanganate in a boiling tube. Heat crystals of potassium permanganate in a boiling tube. Insert a glowing splint into the tube. Heat crystals of potassium permanganate in a boiling tube. Insert a glowing splint into the tube. You have to take the potassium permanganate crystals, then put it into boiling tube and heat. What happened? After that, you have to insert a glowing splint. Why we uh, insert a glowing splint, Lamai? To check what gas is getting out. That means especially glowing splint we use for oxygen gas when it burns again. So fill this table. Okay. And the third one, take some copper sulfate solution into test tube and add a clean zinc granule into it. Copper sulfate, you have to add clean zinc granule. Take a little barium chloride solution into a test tube and add a sodium sulfate solution into it. Give a try to do this activity. So I'm gonna give you the answers later. So you have to fill this table. According to the nature of chemical change, they can be classified into 4 types. They are as follows. What is the first type? It's a chemical combination reactants. As it was told in previously here, formation of new substances by combination of 2 or more substances. So they are the combination ones. And chemical decomposition reactions, they are the second ones. From 1, you are going to turning one substance into 2 or more. You are going to prepare 2 or more. That is decomposition. And third one is single displacement reaction. So the place of a one element got changed, and double displacement, it is the place of the double two elements get changed. You'll understand when we talked about it. Let's go to the chemical combination reactions first. So this is the formula, common reaction formula we use for this one, combination one, because A and B, by the combining A and B, we form a new substance as C. So this is what happened in all these uh, reactions. Consider the first reaction of 16.2. In it, magnesium reacts with oxygen in the air, forming magnesium oxide here in the first reaction. So magnesium burns in the air. That means magnesium get combined with oxygen and produce magnesium oxide. So this is the balanced equation, because you can see it has two in here and in here. So this is a balanced one. 2 magnesium, 2 oxygen. Here we have 2 in both. Here 2 elements have combined to form a new compound. So magnesium and oxygen has combined to form a new compound. The formation of a new compound by the combination of elements with elements, or elements with compounds, or compounds with compounds, is known as chemical combination reaction. Here see, formation of a new compound by the combination of elements with elements. Carbon with oxygen, it forms carbon dioxide. Or elements with compounds. Mainly we don't have elements with elements in here. This is a compound. So this is an element with compound. Carbon is an element, one single atom, and oxygen is a compound. So it is elements with, it is elements with compounds. And what is compounds with compounds? This is element with compound. This is also an element with compound, because carbon is element, carbon dioxide is a compound. And what are compounds with compounds? They are calcium oxide and H2O, hydrogen gas and chloride. So they are compounds with compounds. See, and the common reaction we talked about it. Then we are going to talk about chemical decomposition reactions. Okay, chemical decomposition reactions. In there, this is a common reaction formula, because one compound prepare two other compounds. Okay, so A convert into B and C, two other compounds. One compounds convert into two other compounds. So here you can see the production of oxygen. So this is a formula we used in preparation of oxygen, one formula. So here you can see potassium permanganate is converted into potassium manganate, manganate dioxide, and oxygen. So reflect on the second reaction in activity 16.2. In that reaction, potassium permanganate decompose under the influence of heat to form other compounds and elements. So potassium permanganate, KMnO4, KMnO4, after heated it convert into K2MnO4, K2MnO4 and MnO2 manganese oxide and O2 oxygen. So we have potassium permanganate, it convert into potassium manganate and manganese dioxide and finally oxygen. Okay, so this is a decomposition reaction. So here they have given the definition. The decomposition of a compound giving other simpler compounds or elements. So here by the decomposition of compound, it should be definitely a compound, because element can't decompose into simpler elements. So it should be a compound. So decomposition of compound giving other simpler compounds simpler compounds, simpler compounds or elements, or compounds and elements. All are same, simpler compounds or elements and simpler compounds and elements. Here this is a compound, so it gives simpler compounds. See, simpler compounds. And this is a compound and it get decomposed and gives simpler compounds. See here, this is a compound and it gives simpler compounds and elements. See, here we are getting an element too. So see, calcium carbonate convert into calcium oxide and carbon dioxide. Hydrogen peroxide convert into water and oxygen. Silver oxide convert into silver and oxygen. So after that we are coming to single displacement reactions. Single displacement reactions. So we have to discuss about single displacement and double displacement. After that, chemical reactions. Reactivity of metals. An interesting lesson is coming. So before that we have to finish these two lamai. Yeah, single displacement. Focus your attention on third reaction of activity 16.2. In that reaction, zinc metal react with copper sulfate and freeing copper metal and forming zinc sulfate. So the sentence is somewhat longer, so just go through the equation, then you understand it. So zinc with copper sulfate. So zinc is like this and copper sulfate is like this, and finally what happened? This zinc is goes with this sulfate and it ended up as zinc sulfate, and copper just get removed. So copper is replaced. Copper in here is replaced by zinc. Okay, the reaction in which an element displaces another element. An element displaces another element in a compound, occupying its space and forming another compound are referred to as a single displacement reaction. Okay, so we have some examples like here. See the common reaction, it is A plus BC, so A should go with B or C. Most of the time A goes with C. A goes with C and B get alone. Okay, so here magnesium copper sulfate, so magnesium goes with sulfate and create magnesium sulfate. Copper's good alone. So here magnesium with hydrogen chloride, so HCl. So magnesium chloride is prepared and H2 get its way along. So potassium bromide, so this potassium goes with chloride and bromine get along. The common reaction, okay, we discussed, and we are coming to this double displacement reaction. So just go through this reaction, then understand. Barium chloride and sodium sulfate. Here we have in single, this barium goes with sulfate. Yeah, that is correct. Here also it happens. Barium goes with sulfate and create barium sulfate. And tell me what about these other remaining two. So the sodium and chloride is remain. So what happened to it? It prepare sodium chloride. So this is a kind of reaction which has double displacement. Earlier just one displacement and one element get along. Compound or element get removed and be alone. Here both get displaced. So a reaction in which an element or a radical contained in a compound is exchanged with an element or a radical. Anyway, it is exchanged. Another compound with an element or a radical in another compound is called a double displacement reaction. A few other examples for double displacement reactions are given below. A few other examples for double displacement reactions are given below. It is ferrous sulfate. Ferrous should goes with ferrous OH and make and OH. Ferrous should goes with OH and produce ferrous hydroxide. So the sodium goes with sulfate and produce sodium sulfate. Here this chloride this chloride goes with sodium and prepared sodium chloride. And what about calcium? It goes with carbonate and produce calcium carbonate. So this is a double displacement, and we can see this common reaction formula they have given us here. If AB plus CD, this A goes with D and prepare AD, and the remaining B goes with C and prepare CB. Chemical equation. Okay, now we have to discuss about this part, and I'm going to discuss it in the next video, and gonna stop here, and let's meet in the next video. Okay, thank you.